So I'm so glad that Kim said all of those things about community and working together, because I don't want to spoil my presentation, but it is a bit about that. I'm going to talk about how banks and fintechs can learn from each other. And before we do that, I'd like to introduce who I am, who Adaptive is. A lot of you probably know Adaptive. We have a booth right there in the back. We are experts in building reactive systems and real-time trading stuff. You can read all of that on the screen and talk to us about it in the back. And I myself, why you should listen to me, or hopefully you do, is I have been programming for a decade nonstop, or at least it feels like it's been nonstop. And about 4 years of that has been here in New York in the finance industry. So with all of you amazing people, and I know a lot of you here. And I've been on the front lines of this kind of epic battle that's been waging, the great war between the banks and the fintechs. You guys have probably heard of it, right? But what I'm more interested in is how we can actually learn from each other to build better software. And if we're going to summarize the state of things, I guess we could go with something like this. So the bank is, historically this big kind of star destroyer zooming through space and shooting down things and capturing as much money as possible. And that's great. That's what we want. And the fintech, however, is a more loosely coupled kind of rebels that maybe are at cross purposes, flying in their Millennium Falcons and going at much faster speeds. So this is the current landscape of the bank fintech war. But what can we do about this landscape to understand how we can come together and create things? And that's obviously community. So to Kim's point, we really need to focus on coming together, and we need to focus on, not like barbecue in the park community per se, but also the open source community, right? And what's cool about this is there's actually there's a hidden side to this as well. So there's the kind of the obvious, yeah, you should have your GitHub pages out there, you should list out all the projects you're working on. But there's also a pretty cool tie-in, a hidden tie-in to Conway's Law. So how many of you guys have heard, guys and girls, I'm sorry, have heard of Conway's Law? Can I see some hands? Okay, that's like 20%, 30%. That's like half of probably those of you have heard. That's okay. So basically, if you're going to sum it up, it's that an organization structure affects the software products that that organization produces. So, I mean, really, it's the communication structures that underlie those things. But let me just give you a little kind of more hands-on example for how this works. So let's say that we have some pretty cool people. We have our finance bros, Tad, Chad, and Brad, and they're building out this really cool application. They're best friends, and they're building out this application. So these are files, right? Let's represent a software project as a set of files. And that's what each of these dots represent. And what you can kind of see happening below is a dependency matrix. It's if I have a file that depends on another file, it represents a black dot in this square, okay? So this is all fine and dandy, but as you can see, this is a tightly coupled organization. And we have people that are building out a software project together and creating a dense matrix, something that might eventually look like this. There's going to be lots of files, and there are going to be lots of arrows, and it's become more and more dense. But on the other hand, we might want to create a more modular structure, okay? So an organization that is bounded by APIs for different modules. Who here likes modular programming? I know NPM does. I see a lot of people. That's good. So hopefully I don't need to tell you why modular programming is great, because it's great. And I could do a whole thing on that too, but I don't have much time left. So, but as you can see, we have a set of modules that now are interdependent amongst themselves, right? But then at the whole, they connect to maybe some larger API, okay? So this is already a much less dense dependency matrix. It's going to cost a lot less. And the really neat thing is that this has been done on a larger scale. So there was a research study that was released in 2011 or so that went over a set of projects that are similar in scope, similar in function, and some of them were developed closed source in small companies, and some of them were developed open source from the start. And the closed source one here is OpenOffice Write. I know it sounds open, but it started out as being called StarWord, which is a horrible name. And then Abasoft was open source from the start. I honestly haven't heard of either of these, but the data is what's important, all right? So the Abasoft word is loosely coupled, OpenOffice tightly coupled. So on the left-hand side here, we have the open source, more modular software. On the right-hand side, on this really dense, insane dependency matrix, we have the tightly coupled software. So this doesn't look like much. I kind of hate the graphics that they put into the research paper. But the important thing is this. So the open source from the start software has what they call propagation cost of 8%, which means at random, if I change a given file, it will cost 8%. There is an 8% chance that I have to touch another file in my software. But on the closed source project, the one that was developed with few developers, without community, it costs 42%. So it's 5 times more costly to make changes in the software that was written in a smaller, more closed-off environment. So that's a pretty huge, and it's not just this one project. It was all of the ones that they found in this research paper followed this same pattern. So given that, what can we do? Well, I mean, there's kind of the obvious, we can actually use open source software instead of just talking about it, which I know a lot of us do. The kind of attitudes toward this are shifting, but importantly, we can understand the differences and the kind of macro level of Conway's Law, but also this micro sense that the actual code that you write does change depending on how your organization operates. So it's cool to have stuff on open source, but it's cool to use like the right stuff on open source that lots of people contribute to with cross purposes. And when we come together and form a community, in just the manner that Kim described, and work on software that has many contributors, and we reevaluate our relationship with those projects, that is truly when we can come together and create software that works really well, but also costs less to maintain in the long run. So thank you very much.